Hi, my name is Rodrigo. This is the final project and it's about mocap or motion capture. So, what is it? This is a technology that records the movement of people and objects and then transfer it to a corresponding application. And this application gets all information and creates a body from the special points that we are using in the person body and create an image like a 3D or can be a 2D. We have many applications. We have gaming, and this is nowadays gaming has evolved to the point where you have human-like or actually humans playing the role of the protagonist of the game, and this technology helps them to transfer that movements and make them look realistic or make them the way they want to be. This also applies to films where you have a person and can be transferred or no can be created like you have in Lord of the Rings or many other movies. Like for example we have Thor. This is about the last movie that we have Thor and his friend. And as you can see on the first image, the one from the left, we have the actor. And this, well, it doesn't look a lot like the final product. We have a normal person, like around 1.7. And this person has a bodysuit that has a lot of triangles and different shapes. We have that this will get more into this presentation, that it helps to create this helps the people that are programming to get this body and make them the way they wanted to. So we have two other applications. We have sport therapy and healthcare. So how does this work? Is based about the theory of reflection of light. We have a ray of light that crashes or incident to a mirror, or can be any like reflecting surface. This ray is then now reflected, and yes, it reflected with the same angle that it has in the beginning. So if a ray enters at 45, it will get out or reflect in the same angle. It does not have a different angle of exit, like we see on this GIF. We have a ray of light coming to a surface or a mirror. In the first one, we have that the ray doesn't get reflected because there is there's not an optimal reflective surface. In the second one, we have a mirror. It can actually reflect light pretty well. So we continue with this. We have the mocap follows, we can say, three principles or three most biggest ways to create this 3D image, and one of them is optical, like retroreflective markers. These are the spheres that we see on the body, or as we see on this image of Thor, we have that strings, that triangles. Those are actually reflective. It's a reflective bodysuit. So it actually works the same, as we're gonna see more into it. We also have that these markers we can actually use light emitters. This could be LEDs or any light source. And we have inertials. This can be rotation rates, gyroscopes, magnet or accelerometers. So materials varied from form to any other technique. This one is about the optical, since it's the most used in biomechanics laboratories. So let's start with the ones that are little spheres around the body. These are rubber balls with a reflective tape or a paint. As we can see, this helps to reflect the light coming from a camera, actually an infrared or a high speed. This beam gets out from the camera and into this sphere. Now this sphere reflects the light back to the camera or any other camera that is on this scenario. We can, as I told you, we can change these rubber balls to LEDs. This can also work the same using maybe a different camera, but will function the same way. Okay, so I told you a little bit about how does it works. That you need a camera that shoots infrared light, and you need an object that can reflect this light. So this light actually goes to the camera, and the camera creates the camera sends this signal to the software or the computer. As you can see here, we have four parts. We get the optical tracking, that are the markers getting on the body. If we connect these points, we can have different bones or structures around this 3D image. We can have the femur, the humerus, radius. We can have an object shaped like a skull, and a torso and legs. We also have articulations, and we can make this skeleton to be more realistic, as we can see on the final product, or stay this way, like some sticks and stones. So what is the objective from this? We have that in medical institutions or medical research laboratories, we have people that analyze the movement of any person that has any illness that may affect the gait cycle, or people or patients that uses prosthetic limbs, as we see. Okay, so with this technique, the optical mocap, we have that it helps to diagnosticate mechanical problems. We can use it on sports, or we can use it on persons or patients who maybe lost part of the function of one of the limbs, mostly their legs. And as we can see on the either image, we have that we create a 2D image from a body, and we can see that the person has a problem with their leg. So maybe we can see on the 3D that this person has a longer leg or a shorter one, or maybe we can see that their spine is actually bent to one side or the other. So let's talk about the pros and cons about this. We have that this technique is actually pretty cheap because it doesn't compare to mechanical optical. To mechanical, we have that you need a big bodysuit from different sensors and potentiometers, and we also have that in optical motion capture that you only need a camera that can shoot infrared and some reflective tape, so it's pretty cheap and pretty lightweight. And also, since you are not using a big metal bodysuit like you will use in another or different technique, we have free range of movement. You are not limited by the bodysuit. So the cons about this: if you're using reflective tape on the outside, you will have very interference by the sunlight and create bad, or yes, it will create a different image if using sunlight than if you use a controlled environment. And the camera, since the camera is still, you cannot move it. You have that some reflective balls can be obstructed by the same body. So if you have a marker here and the camera is right over here, you will not see that marker. So it's important to use multiple cameras or get a full image around all the body. Let's talk about the future. We have that, like I told you, we can use multiple cameras to create a 360 view of this person, and we can also use LEDs, and we can use, like nowadays we have this called LiDAR. This sensor is like a camera that uses ultrasound to get objects around the sensor. Like you can see, this technology is now used on cars, and it actually creates a pretty good image about cars that are in front, or any, like for example, you can see the lines of the road, you can see these buildings, you can see people, and this technology helps nowadays. It helps cars to be maybe not 100% human free, but it creates a safety feature from, for example, if a person runs across the car will stop because he will see something that you didn't see. And this LiDAR sensor actually works pretty well on dark environments, because this is not using light, so it's using sound waves that we as humans cannot hear, and we can create this map around this small sensor. You can also find this on iPhones. The newest one has this LiDAR sensor that helps create better image and better deep of field. And that's it.